Welcome back to geometry. Welcome back to mathematics for senior secondary school by Obafemi Omoni. In this class, in this lesson, we'll be taking some examples on the lines and triangles theorem and types of triangle which we have discussed in the last two previous classes. So if you have not watched them, please go back and watch them. Then click the red button to subscribe to this channel so that you can also get the video when I upload it newly as they hot, so that you can get it. Also click on the notification button. So thank you. Let's solve this. Mathematics is as simple as drinking pure water. All you need in these triangles to be able to solve them is to analyze each of the diagrams. When you have analyzed them, look at the properties that fit into them, then try to use them to solve it. Looking at this question number 1, I will label it A, B, C, D. Solution. Example 1. So, looking at this A, B, C, D, I'm asked to look for X. Considering triangle ABC, we will see is A or is an isosceles triangle. Consider triangle ABC. It is an isosceles triangle. So, remember the properties of isosceles triangle. Two sides are equal and two base angles are equal. So if this is 70 degree, it means this is also 70 degree. So we have ABC, angle ABC must be equals to angle ACB. Which is equals to 70 degrees. So why? So we said the base angles of isosceles triangle are equal. So therefore I can say that X plus 70 plus 70, S plus 70 plus 70 is equals to 180 degrees. You must write the reason at the front. Sum of what? Angles in a triangle. So sum of angle in a triangle is equals to 180 degree. Then I have X plus 140 is equal to 180. Then I have X to be equals to 180 minus 140, so is equals to 40 degrees. That is the answer. So we move to example to get the value for our y. To get the value for our y, we have to consider the triangle BCD or a triangle DBC. And this triangle BDC is an isosceles triangle also. So consider triangle BCD. Triangle BCD is what? Is an isosceles triangle. Is an isosceles triangle. So if it's an isosceles triangle, it means the two base angles are equal. So this side is equals to this side, hence this angle must be equals to this angle. So if this angle is y, this angle must also be y. So I will have my triangle BCD CD must be equals to angle CBD. This must be equals to this, hence which is equals to y. Why did we say that? Base angle of what? Isosceles triangle are equal. So if they are equal, then I have y plus 118 is equals to 180 degree. Why? Summation of angles in a triangle is 180 degrees. So I have 2y equals to 180 minus 118. So when you press your calculator and subtract that, you have it to be equals to 62. Y equals to 2. So y is equals to 62 divided by 2, which is equals to 31 degrees. So we have seen how we used the theorem to solve for x and also solve for y. In example number 2, example number 2, example 2, example 2, I have also an isosceles triangle with an external angle. So I will label it the line segment that form the triangle. I'll label it the EFGH. So looking at what we are given here, we can see that angle EFG, considering considering triangle EFG, it is an isosceles triangle. So if it is an isosceles triangle, remember the theorem, the two sides are equal, which you have seen by this notation. Two base angles are equal, so this angle must be equal to this angle, so this must also be n. So we have angle EFG must be equals to angle that's EGF. So if these two angles are equal and two of them are equals to n, then I want to get this angle E, this angle E. So I'll call this R, angle E. So I can say my angle EGF plus angle FEG plus angle EFG must be equal to 180 degree. Why? So I said this one, base angles of isosceles triangle. Here, sum of angles in a triangle. are summed to 180 degrees. Then when we add them together, so I have n plus f e g plus n is equal to 180 degrees. So angle FEG is equal to 180 minus 2n. Any problem with this? So I have gotten this angle. Then if we go back to our first lesson, we will discover that sum of two opposite adjacent angles in a triangle is equals to its exterior angle. So this exterior angle here, 144, is equals to the sum of these two opposite adjacent angles. So this one plus FEG, n plus FEG is equals to 144. So we can say F plus n plus FEG is equals to 144. Why? You state the theorem, that is exterior angle of a triangle is equal to sum of the opposite adjacent angles. So therefore n plus FEG is 180 minus 2n is equals to 144. So you have it to be equals to 180 minus n is equals to 144. So n is equals to 180 minus 144. So n is equals to 36. So thank you. Then we'll pick example 3. Example 3. Example 3. So pick example 3. We have this triangle and we are given external angle. So I believe you should be able to solve this. Step 1, we label this triangle. So when we label this triangle, we have what? This GH, I, J, K, L. So then, if this is U, we consider this triangle IJK. Consider triangle IJK. It is an isosceles triangle. It is an isosceles triangle. So if IJK is an isosceles triangle, so it means its two base angles are equal. Its two base angles are equal. So this side by notation is equals to this side. Hence the base angles are here and here. So if this is U, this is also U. Any problem with that? No. So then we move to the next theorem, which we used in the last one, that exterior angle is equals to sum of the two opposite adjacent interior angle. So the exterior angle here is equals to sum of the two opposite adjacent interior angle. So I have my U plus U to be equals to 56. Why? Exterior angle of a triangle is equal to sum of opposite adjacent interior angle. Sum of opposite adjacent interior angles. So then you have 2u is equals to 56. So you have u to be equals to 56 divided by 2, which is equals to 28. Then we move to example 4. So in example 4, we want to find n and m. N and m. N and m. So how do we get n and m? This angle here is 35 and this is an isosceles triangle. If we cover this, we have an isosceles triangle because by notation this side is equals to this side. So therefore, if this is 35 degrees, this will also be 35 degrees. Then according to the theorem we did the other time, that an exterior angle, so if we look at this angle, it is an exterior angle for this triangle. For this triangle that we see here, this isosceles triangle that we see here, this place is an exterior angle to it. So this exterior angle is equals to sum of the opposite adjacent interior angles, which is 35 plus 35 is equals to 70. So this exterior is equals to 70 degrees. So if this exterior is equals to this 70 degree, the exterior that is equals to this 70 degree is forming another triangle with this place. So if we can see, it is forming another triangle, and considering this triangle is an isosceles triangle. This isosceles triangle, these are the base angles. These are the base angles. So the base angle, if this one is, and they are equal, so if this is 70 degree, m is automatically 70 degree. So m is equals to 70 degree. Base angle of an isosceles triangles are equal. Then we want to get n. So looking at it, we have m to be 70, here is 70, here is n. This is a triangle, so sum of angle in a triangle is 180 degree. So we now say sum of angle in a triangle is 180 degrees. So we have m, which is equals to 70, plus 70 degree plus n is equals to 180 degrees. So we have what? 70 plus n equals to 180 degree. So we have 140 plus n equals to 180 degree. Then we have n to be equals to 180 minus 140 degrees, which is equals to 40 degrees. So apologies, I'm trying to manage this paper so that we can get the best out of it, and so that we can minimize space and will not be moving papers and papers and papers. So I apologize for that. So example 5. So looking at this example 5, considering this example 5, what do you think about it after considering this triangle? Yes, you are correct. This big triangle that we have here, ABC, is an equilateral triangle. It's not an isosceles triangle. It's an equilateral triangle. For it to be an equilateral triangle, it means all its angles must be 60 degrees. So check the previous lesson about it, 60 degrees, and it means this complete angle here is 60 degrees. So if that complete angle there is 60 degrees, so we can get this x we are asked to find. How can we get it? So considering this smaller triangle, this angle x is an exterior to this triangle DBC. this S is an exterior angle to DBC. So if it's an exterior angle to DBC, it means the sum of the opposite adjacent interior angle must be equal to X. So 46 plus 60 is equal to X. So we now have 46 plus 60 degree is equal to X. Why? Sum of the opposite adjacent interior angle is equals to 100 is equals to exterior angle. So when you add this and this together, so I have my X to be equals to 106 degree. So thank you for watching. I think you've seen how I have maneuvered it. My example 1, I solved it in detail. Example 2, the same thing, I solved it in detail. Example 3, I had to solve it the way I have solved it because during your objective question exam, you are not expected to start solving, but just the way to analyze it, I showed it. Example 4, the same thing. Example 5, the same thing. So if you have any question you want to ask me, please send it to the comment section or the comment box, and I will attend to it as soon as possible. Thank you.